All right, so we're on page 723 today, and we are going to be working with inscribed angles. And we can say that an inscribed angle has a vertex on a circle and sides that contain chords of the circle. All right, so in a circle here, we put the center in here, center C. If I put a point anywhere on this circle, point A, and just draw or create an angle, this angle A is an inscribed angle. All right, any angle that you draw inside of a circle where you put the vertex of the angle on the circle, and then you create this inscribed angle with two chords. All right, and theorem 10.6 gives you rules related to an inscribed angle. We're going to say if an angle is inscribed in a circle, then the measure of the angle is 1/2 the measure of its intercepted arc. So if we go back to this circle, we add points B and D. This inscribed angle formed this arc BD right here. That's its intercepted arc. And what this theorem says is that the measure of angle A is equal to 1/2 the measure of arc BD. We're also going to say that the measure of arc BD is equal to 2 times the measure of angle A. So if we know the arc measure, we divide it by 2 and it gives us the angle measure. So if this is 60 degrees, then the measure of angle A is 30 degrees. And if we know the angle measure, we multiply it by 2 and it gives us the arc measure. So if you look at example 1 over on page 724, we can apply these rules for practice. And we're going to find each measure. We're going to find the measure of angle P. And we're given this circle. Kind of got this picture going on. All right, so if we look at angle P right here, angle P is the angle in this inscribed angle, and its intercepted arc is this arc MN. So the measure of angle P is equal to 1/2 of 70. And half of 70 is 35. So our angle P in here is 35 degrees. If we need to find the measure of arc PQ, since we know this angle measure here, angle N is 56 degrees, and PQ is its intercepted arc, then the measure of arc PQ is equal to 2 times 56. And 2 times 56 is 112. And we're in degrees. Any questions there? Pretty straightforward. Let's look at the second part of that example. We've got this circle. C, D, E, F. And we're told that angle D in here is 40 degrees. Arc DE is 98 degrees. So we got to find arc CF and we got to find the measure of angle C. So the measure of arc CF is equal to, well, angle D right here is 40 degrees and it's an inscribed angle, and arc CF is its corresponding arc. So C to F is twice as big as the 40, so we do 2 times 40. So arc CF is 80 degrees. If we need the measure of angle C, all right, angle C is right here. It corresponds to arc DE, all right? That chord ends at, we have chord CE and we have chord CD. They form this arc. So if we need the inscribed angle and we know its arc, we take 1/2 or we take the 98 and we just divide it by 2. And 98 divided by 2 is 49. So angle C in here is 49 degrees. All right, and keep in mind that we still have a triangle in here, or in this case, we formed a triangle in here. So if you were asked to expand on that, you could find the third angle in this triangle. So if we take 180 minus 40 minus 49, we get 91 degrees. So we get an angle inside this triangle that's 91. All right, if you keep in mind your rules regarding vertical angles, if that angle is 91, then the angle on the other side of its vertex is also 91. Okay, we've got linear pairs of angles in here. So the angle above the 91, the linear pair with the 91, is equal to 180 minus 91. So this angle is 89 degrees. And the angle vertical to it is 89 degrees. So there's quite a bit of information going on here. So don't forget about vertical angles and linear pairs of angles if you're asked to find other angle measures. Take a look at theorem 10.7 on the bottom of 724. And what it says, if two inscribed angles intercept the same arc, or congruent arcs, then the angles are congruent. So if we take a circle, if two inscribed angles intercept the same arc. So let's take an inscribed angle and let's intercept an arc. So here's angle A and it's gonna form arc BC. Now, if we draw another inscribed angle that intercepts the same arc, we could put point D down here and form a chord from D to B and from D to C. Well, what you have now is both angles. Angle A intercepts arc BC, and angle D intercepts arc BC. So if two inscribed angles intercept the same arc or congruent arcs, then the angles are the same. So look, we just kind of said that if this was 80 degrees, if arc BC is 80, then angle A would be 40. And by that same rule, if arc BC is 80, then angle D is also 40. So that's what this theorem is telling you. So we've got a picture, example 2 up on the top of page 725, where you're going to do a little bit of algebra and you're going to apply this rule. Got another circle. Got angle T and angle U, and they both intercept arc SV. You're told that angle T in here is 3x minus 5. And you're told that angle U is 2x plus 15. Find the measure of angle T. We need the measure of angle T. So here's our angle T. All right. It corresponds to arc SV. And angle U also corresponds to arc SV. So we know that if two angles intercept the same arc, then the angles are equal to each other. So we're just going to set a equation up where 3x minus 5 is equal to 2x plus 15. Subtract 2x from each side. So we get an x minus 5 that's equal to 15. Add 5 to each side. So our x is equal to 20. So if our x is equal to 20 and the measure of angle T is equal to 3 times x minus 5, the measure of angle T is going to be equal to 3 times 20 minus 5. And 3 times 20 is 60, minus 5 is 55. If you want to double check your math, you just substitute it. Substitute that 20 into the other equation as well. So if we take 2 times 20 and add 15, we get 40 plus 15 is 55. So we've got two of the same angle when we substitute the value of x, so our math is correct. Any questions? All right, now we're told the guided practice says if the measure of S is 3x, the measure of angle S equals 3x, and the measure of angle V equals x plus 16. Find the measure of angle S. So look what we've got here. We've got an angle. We've got angle S. We've got angle V. They both intercept arc TU. So we have two angles that intercept the same arc. If two angles intercept the same arc, then they're equal to each other. So what we get here is that the 3x plus 15, or I'm sorry, the 3x is equal to the x plus 16. Angle S is congruent to angle V. So subtract x from each side. 2x would equal 16. divide both sides by 2, and our x is equal to 8. So if our x is equal to 8 and the measure of angle S equals 3x, well, the measure of angle S then is equal to 3 times 8, which is 24. And if we needed to find the measure of angle V, we would just say that 8 plus 16, and that's equal to 24 as well. So our math is correct, and we know both angle measures. All right, any questions on inscribed angle? Inscribed angles, or finding the measure of an inscribed angle or its intercepted arc. The angle is half the arc. The arc is twice as big as the angle. All right, then your practice for today is going to be on page 727. One through 6, and then 11 through 20. Please make sure you're doing the odds and that you're checking the odds in the back of the book.